In times where the competition for funding and positions is increasing, academics are increasingly questioning whether the metrics that we currently use to evaluate research and researchers are really doing what they should. Special research projects are being funded to evaluate evaluation metrics. In this episode, we talk about so-called altmetrics or alternative metrics. We will learn what they are, how they can be used, what the advantages and disadvantages are, and why they might not actually be ready for global use in the sciences. As always, you'll find a summary of this episode in the show notes on our website www.scienceforprogress.eu.
I'm Steffen Lemke. I'm a PhD student and research assistant from Kiel in northern Germany.
Steffen works at the Leibniz Information Centre for Economics, ZBW.
My original academic background is from business information systems, and now over the past 2 years I've been working in the metrics project, which is a project from the realm of information science.
In the past we talked about research metrics as a means to evaluate researchers, but there are other reasons why we would want to evaluate research.
The amount of scientific publications that is published every year is quickly rising. There are estimations right now that about every 8 to 9 years the total amount of publications that's available worldwide doubles. And I guess that's the main and most pragmatic reason for why we need metrics to somehow prioritize what might be more relevant than other research.
Metrics can help researchers who are new to a field to find out which papers are the most relevant and can begin their literature search with those. But organizations are also interested in evaluation metrics.
Funding agencies might be interested in a tool that they can use to see how their projects that they are funding are performing. The same for governments who have an interest in knowing how well individual institutions are performing. And that's why they need indicators of some sort, why they need numbers, and that are those metrics for research evaluation. Metrics that somehow quantify the relevance of the research outputs.
Steffen works within a project called the Metrics Project. Its written name has an asterisk, leading the word metrics. It's a hint towards search engines, where the asterisk indicates a wildcard that may mean anything.
In this project, we try to include the variety of metrics for research evaluation that's out there. For example, Altmetrics, but also bibliometrics and usage metrics, all those different classes of metrics. What we want to know is how are these metrics used right now by researchers? How do researchers understand them? How are researchers influenced by them?
So for this experiment, the Metrics Project is interested in how researchers weight the information given to them when deciding which articles they should read.
We show them here in this scenario, you have been searching for literature. Please, based on these numbers that we provide you with, how, in which order would you read these articles? For example, Article 1 has been mentioned on Twitter 500 times but has only 10 citations. Article 2 has 25 citations but has no mentions on Twitter. And Article 3 is something in between, something like this. And then we let our respondents tell us how they would arrange these articles, in which order they would read them.
The most established metrics currently in use are the journal impact factor and the H index. They both use citations as their basis. I already talked about the journal impact factor with Björn Brembs in episode 9. So just as a reminder,
it tells you for a journal in one single convenient number the average amount of times that articles that were recently published in that journal get cited. Now, the problem with citations overall is that the distribution of citations over publications is heavily skewed. Very few publications receive very high amounts of citations. At most, publications receive almost none or even 0 citations. About 75% of all publications in journals will receive actually lower citation scores than the journal impact factor would suggest. Intuitively, you might think that if I publish in a journal with journal impact factor 10, then I'll probably get 10 citations, but that's not the case. Most articles just get fewer citations.
But Steffen has been looking into the social sciences specifically, and it appears that these fields struggle with the application of the journal impact factor in ways that are specific to the nature of the social sciences. As a metric for the popularity of a journal, it can be very useful if your work isn't published in journals.
Many fields from the social sciences rely a lot on book publications and monographs. And those, for example, are underrepresented in the citation indices that are used to calculate the journal impact factor. Also, in many social sciences, there is this heavier dependency on local contexts. While, for example, in physics or chemistry, almost all publications might be in English, in many social sciences, there might be reasons for authors to publish in their own native language, which may not be English. And the journal impact factor is heavily biased towards English publications because those high impact journals are in English. And these are reasons why some fields struggle particularly with the journal impact factor.
And of course, the problems that lie in the nature of the underlying data, citations of journal articles, also apply to other citation-based metrics, like the H-index.
The H-index doesn't evaluate journals or publications, but researchers. And the idea there is that if someone, for example, has an H-index of 5, that means that this person has at least 5 publications, which each and every one of them has at least 5 citations. So the H-index, for example, helps to reduce the value of single publications with extremely high amounts of citations, because if you are a researcher and you have one publication and that has 20 citations, then you've still just an H-index of 1. But the H-index also has problems. For example, studies have shown that the H-index correlates with age. You don't want that older researchers just get an advantage by definition, and also the H-index is really bad in comparisons across disciplines. That's a thing that's probably true for almost every metric. Comparisons across fields are probably never a good idea, but with the H-index it's extreme. I think in biochemistry, if I recall correctly, the top H-index is max at about 200 or so. And I think in computer science it's just 100 or so. So yeah, these numbers, please take them with a grain of salt. That's just from the top of my head. I'm not completely sure about, but there are disciplines where the top H-indexes are twice as high as in other disciplines. Another problem with H-indexes is that they are extremely dependent on the data source that you use to calculate them. There are examples for computer scientists who have an H-index of 20 on Google Scholar, but only an H-index of 10 on Web of Science. Cases like these. So, what's now the correct H-index?
The question now is whether we can find better ways to evaluate the work that researchers have done, for example, by using Altmetrics.
Altmetrics is an umbrella term, so it comprises quite a lot of different kinds of individual indicators. Part of them are so-called usage metrics. For example, download counts. That's kind of a usage metric. But Altmetrics also add to that every kind of interaction with a scientific product that somewhere happens on the web that can be counted. The most intuitive example maybe comes from social media. Many altmetrics are social media based. For example, one example for an altmetric would be we count the number of times that a scientific publication is mentioned on Twitter, or we count the number of times that a publication is cited on Wikipedia, or the number of times that it's bookmarked on a literature management software like Mendeley or Zotero. Those are all altmetrics.
Due to their nature, altmetrics have several advantages over citation-based metrics like journal impact factor and H-index.
One of the main advantages is that they are so fast, that you can fairly reliably compute the altmetric impact of a recent publication very soon after its publication, while for citations you have to wait for usually years for citations to accumulate. Another very promising aspect of altmetrics is that they can be calculated for such a vast diversity of different scientific products, because if you look at citations, then usually the only thing that really matters are journal articles. That's what researchers get payment for in quotations. That's what counts. And with those altmetrics, those web-based signals, you have the option of also counting how often presentation slides, for example, are used or shared, or how often software code is downloaded and used, or blog posts, all these things which would deserve to count in the evaluation system of science. And altmetrics make that possible, where citation don't. Another advantage of altmetrics is that altmetrics, at least ideally, are able to capture impact that happens outside of academia. With citations, you just capture what other researchers deem to be important and deem to be relevant and impactful. And of course, in many use cases, that's just what you want. But altmetrics have this additional ability of also reflecting impact outside of academia, among other stakeholders, like the general public, but also policymakers or practitioners who might rely on research findings but might not actively write publications that produce citations. Yeah, those are some of the biggest advantages of altmetrics.
One of the advantages is the transparency of the underlying data. While citation data is kept behind paywalls, download numbers and social media interactions are openly accessible.
Potentially, if someone claims my article has been tweeted 10 times or has been discussed on Twitter for 10 times, then potentially everyone, at least those people that live in countries where Twitter is available, those will be able to see those tweets. And citations, on the other hand, are usually based on those closed citation indices. The big players, two of them are Web of Science and Scopus. Those are the two big citation indices, and they don't make their data publicly available. They offer their products, for example, the journal impact factor, against payment, and you can't easily see how citation counts come together. You at some point just have to trust them.
Of course, using social media as a data source has obvious problems. One would be the fact that you can pay social media companies to boost your posts. When I boosted the same video on Facebook and Instagram for the same amount, Instagram generated several times more views than Facebook.
There are prominent providers for altmetric data. One of them is just called altmetric.com. Another one is, for example, called PlumX. And what they are doing is they do aggregate signals from different sources. Like in your example, they would aggregate maybe signals from Facebook. I mean, they don't look at Instagram, these two, but in principle, they could look at Instagram, and they aggregate those to a score. That, of course, is also problematic for the reasons you just explained. The signals that happen on Facebook are different than those on Instagram. They mean a different thing. 10,000 likes on Instagram might mean something completely different than 10,000 likes on Facebook, which is why, of course, if you've got the possibility to do so, you should look at individual scores individually and not aggregate them to one number that obscures those differences.
Another problem with metrics based on social media would be that you can game their system. For example, by using bots to boost the engagement numbers of your posts.
That's an absolutely valid point of criticism against metrics, that they can be gamed. One could also say that citations can also be gamed. I mean, there are those stories of citation cartels who cite among each other, even if it doesn't really make sense from a research standpoint, but they help each other to gain citations. But of course, on the internet, it's surely much easier. Then again, this umbrella term altmetrics is very diverse. It includes a lot of things, and probably some of them will be easier to be gamed, like download counts. I mean, it's easy to imagine a bot that just downloads your paper from a certain repository again and again, or like Facebook likes, where you can promote your posts and get better reach. But some of them might be more robust to gaming. For example, bookmarks or Mendeley are one altmetric that gets much hope from the Altmetrics community because it's very good at predicting citations and has very similar behavior to them.
So far, Mendeley seems to be safe, at least when it comes to boosting papers.
In Mendeley, there's no such thing as please promote my publication. There's no inherent feature that allows you to ask for further reach than other papers get. But of course, still the aspect of gaming isn't off the table there. That's also applicable to Mendeley readership counts and probably to every metric that's there. If you start making a metric out of something, then probably people will start gaming it.
Indeed. And companies such as Elsevier, which owns Mendeley, may decide that at that point it may be a lucrative business to sell visibility of research papers on platforms like Mendeley. But that's my suspicion. Another problem for Altmetrics in social sciences is that, as is the case for the citation-based data, social science publications aren't well represented in the data underlying Altmetrics either.
Colleagues did a study for the social sciences and humanities for various fields from those disciplines to see which amount of articles in these fields actually gets any altmetric attention at all. They looked at 10 different sources for altmetrics. For example, they looked at Twitter, they looked at Mendeley, I think they also looked at Wikipedia, and so on. 10 different platforms, and Twitter excluded. On Twitter, more articles get shared, but Twitter excluded. The remaining 9 platforms, for no field more than 12% of the articles received any citation or mention or bookmark ... at all. I mean, this really illustrates well the problems that social sciences and humanities would have right now if they wanted to apply altmetrics.
This is why Steffen and the Metric project did a study on the use of social media by social scientists, which was recently published.
Why don't researchers, especially from the social sciences, make use of those new channels for scholarly communications that are available? Those social networks, but also wikis and other platforms. The most commonly stated concern by those researchers seems fairly trivial at first, because most of the researchers just said that it costs too much time to use those channels to disseminate your research. And of course it's a perfectly valid answer, but seems a bit superficial. Because why does it cost too much time? That's the question behind that. Why do researchers have the impression that the amount of time that they have to spend on dissemination efforts on social media is not worth it ultimately? And when asking for this in the interviews, we got to some more interesting aspects. One very common motive for not using social media stated by the researchers is that you have to deal with an information overload that's heavy to cope with. It's just too difficult to distinguish important and relevant information from nonsense. That's a very common motive. But one motive that I found alarming is that during our interviews, 2 young researchers independently from each other told us that when they are using social media for work at their workplace, even if they are on professionally relevant sites, if their boss comes in, then they close their browser windows because they don't want to get caught using social media. So they've got the feeling that in parts of academia there exists this notion that time spent on social media just can't be working time, that can't qualify as working time. It's nothing you should do as a researcher in your working time. We also got the straight answer in our survey from one participant that it just might seem unprofessional to use social media as a researcher, as a reason for why he or she doesn't do it. And that seems to be a pity because in my understanding, for most types of researchers, I mean, there might be exemptions, but for most types of researchers, research dissemination should be a part of their job. And why not use those extremely efficient communication channels that we have today, those social media channels, and especially so in the social sciences, because the social sciences often claim to address needs that are of particular interest to the public discussion. And then to say, yeah, but my colleagues don't appreciate it if I do engage with people from outside academia on social media, that seems weird and seems like something that hopefully changes sometime. In STEM fields, I might have more understanding for thinking, okay, the general public doesn't need to be involved in this or doesn't need to get the information directly. It's enough if they get it through traditional gatekeepers like journalists.
So the impression that social media was a waste of time and fear to be judged by more conservative researchers who hold that belief appears to be one of the problems. While it's surprising that especially social scientists don't seem to be interested in interacting with the public on social media, they should have a further interest in alternative evaluation techniques for other reasons.
I mean, given the troubles that social sciences have with citations, and given the difficulties that we have to perform fair and realistic citation analyses for social sciences, one might come to the conclusion that they should be even more interested in picking up alternatives in Altmetrics, in new ways of capturing interest in research products. But as the work of our colleagues said, the one that we just spoke about, we see that till now the uptake of those new communication channels is really, really low in social sciences.
Another important aspect is metric wiseness, meaning the knowledge and understanding of metrics to actually make smart decisions about their use.
It's a word that colleagues came up with, one thing we found during our interviews is we had a section in these interviews where we talked about how researchers perceive different metrics for research evaluation and what they think about the current state of scholarship, how these metrics are used. And we always started the segment with asking if you hear these terms, metrics for research evaluation or metrics for scientific impact, just what does come to your mind? What do you know from these areas? And what we found is that almost everyone, even really young researchers that only had started their PhD a year ago or so, they all usually knew of the journal impact factor. And most of them also gave us the impression that they really care about this journal impact factor and they think that it's something that they need to achieve, that they need to have publications in high impact journals according to journal impact factor. And many of our respondents also had heard of the H index before, for example. So they knew about this basic idea of quantifying the impact of research products, but this whole concept of web-based metrics, be them Altmetrics or usage metrics in the form of downloads, all these concepts were completely unknown to them. They never really thought about them and knew of them. And probably that reflects the current state of Altmetrics fairly well. The idea of Altmetrics is not that old. There's one document called the Altmetrics Manifesto, which was written in 2010, if I'm correct. Some well-esteemed colleagues formulated this idea of Altmetrics and what they should bring, what citations can't bring. And in practice, Altmetrics don't really appear so far.
Let's summarize.
One thing is, it seems troubling to me that we have the situation that young researchers feel in some cases actively discouraged to make use of the communication channels that we have today, social media in particular. And the second thing is that what those interviews and surveys clearly showed us is that many researchers could really benefit from more training regarding what those metrics for research evaluation are, what they mean, and especially which limitations they have, because it's a relevant topic for almost everyone working in research. The ways that research is assessed is important for everyone, and in many cases we saw that people know about things like the journal impact factor and the H-index sometimes even, and they try to maximize these scores, but in most cases they don't really know, for example, how the H-index or the journal impact factor is calculated, what it means, and what would be valid applications for it and what would be limitations that tell you, okay, don't use the journal impact factor for this and that. So that's something that I feel that seems to be lacking right now. Maybe PhDs should get just in general a class about how these metrics are to be used or to be understood, so that they know more about how the current research system actually evaluates them.
Overall, Altmetrics may be an interesting opportunity, but not ready for prime time.
It's new, and it's an idea that hopefully will sometime be a really valuable complement to the current methods of research evaluation. But we are far from a situation where we could really say Altmetrics can now replace citations. I mean, that's not what we want at all anyways, but Altmetrics still have a long way to go before they can become really applicable to large amounts of fields of research.
For the summary and further readings, find the show notes to this episode on www.scienceforprogress.eu. And check out the different ways you can support us by navigating to Your Support on our website. If you have questions, critique or suggestions, get in contact by email info@scienceforprogress.eu or on social media @Sci4Progress for Twitter and Facebook. Have a good day. Bye-bye.
Bye.